Hey class, today we're going to look at trig of any angles. So our objective is that you can evaluate the trigonometric function of any angle. So here I have a Cartesian plane here, xy coordinates with all four coordinates, and we have this little saying that goes counterclockwise, all students take calculus. And this is what I use to remember which trig functions are positive in different quadrants. So all students take calculus is like the mnemonic that goes around with it. In quadrant 1 then, remember this is quadrant 1, 2, 3, 4. In quadrant 1, all stands for all trig functions. All trig functions are positive. So if you did the sine of 30 degrees, you'd get a positive answer. If you did the cosine of 30 degrees, any angle in that first quadrant, you'd get a positive trig function. In quadrant 2, only sine functions are positive. So only sine functions are positive. So if you did the sine of 120 degrees, you get a positive answer. If you did the cosine of 120 degrees, your answer would be negative. So only sine functions are positive. Remember that cosecant, like CSC of theta, is also a sine function. It's a reciprocal. So CSC of theta is also positive in the second quadrant. So all is all. Student starts with S, so it goes with sine functions are positive. All students take. Starts with T, so tangent functions are positive here. Tangent functions are positive in the third quadrant. And that does include cotangent then of theta because it's the reciprocal of tangent. And then the last one, calculus, is representing the C for cosine. So cosine is positive. And then secant goes along with cosine, so that one is also positive. So all students take calculus. They're all positive in the first quadrant, only sine is positive in the second, tangent's positive in the third, calculus is cosine is positive in the fourth. All right. Let Q be any angle in standard position with XY as a point, except for the origin, on the terminal side of Q. And then these are the ratios for these functions. So the way that I remember this is I draw it out every time. So we're looking at, here's the initial side, and here's the terminal side, and XY is a point on that terminal side, and there's your angle. So I prefer to draw this out in the first quadrant. So I look at, okay, here's my angle, and I'm going to call this theta. And then I'm going to choose a point on my terminal side right here, and I'm going to drop down a height. I'm going to make it a right angle. Then I can say that the distance from the vertex to this right angle is x distance, because this is an xy point. So I'm going over x. And then up, I go up amount of y. And then if I think about this as part of my circle, this point from x to y will be my r, my radius. Then I can use SOHCAHTOA to find these ratios. So if I find SOHCAHTOA, then sine, so I use this same triangle every time. Across from this theta, the y will be my opposite side. The x is always my adjacent side. And then the r, the radius of my circle, is going to be my hypotenuse. And then that's where these ratios come from. So sine equals y over r because sine is opposite over hypotenuse, so y over r. Cosine is x over r because cosine is adjacent over hypotenuse, so referring back to this triangle I've drawn. And tangent is opposite over adjacent, so y over x. So opposite over adjacent. And then remember that cosecant goes with sine, so it's the reciprocal. Secant goes with cosine, so it's the reciprocal there, and cotangent goes with tangent, so it's a reciprocal there. So I always refer back to this drawing right here. And then we use this formula to find our r value. So if we're given any xy point, we can solve for the radius of the circle using this formula that I highlighted. That formula comes from the Pythagorean theorem. So if you look at the triangle I've drawn, the Pythagorean theorem says that the sum of the squares of the legs equals the hypotenuse squared. So it's x squared plus y squared has to equal the r squared. So solving for r, you take the square root of both sides. So x squared, the square root of x squared plus y squared equals r. So that's where that comes from. So we're going to use that formula to find our radius, and then I'm going to refer back to the triangle here that I've circled to find these ratios. So I don't memorize the ratios. I always refer back to finding the ratios using that drawing in the first quadrant. So I'll show you what that looks like. So let -4, -3 be a point on my terminal side. So -4, -3 is down here. That means that my theta starts at the x-axis, this is my initial side, goes all the way down here and ends where this point is right here. So this is the theta that I'm solving for these trig functions. And so my xy point, -4, -3. So this is x, this is y. I will need to solve for r then, or my radius. Whoops. Close this here, sorry. I'm going to use the formula, square root of x squared plus y squared. So r is going to be the square root of -4 squared plus -3 squared. That's going to be the square root of 16 plus 9, or the square root of 25, which gives me 5. So my radius here is going to be 5. So I have x, y, and r equals 5. So now I need to remember all the ratios. In order to remember the ratios, I use this special right triangle that I draw in the first quadrant, and I use it every time. So I know that this is my x distance, this is my y distance, this is my r, and I put my theta here. And then I know from SOHCAHTOA, my ratios, I know that across from the angle is opposite, next to is adjacent, r is always hypotenuse. And so sine of theta, this degree that I drew in my original drawing, will be opposite over hypotenuse, so it's going to be y over r. So using my y will be -3 over 5. Cosine of theta is going to be adjacent over hypotenuse, so x over r. So using my xy point in r will be -4 over 5. And tangent of theta will be opposite over adjacent. And so I'm going to end up with -3 over -4, which is going to be +3/4. Notice that sine and cosine are negative and tangent is positive. This is all students take calculus. The terminal side ends in the third quadrant, so only tangent and cotangent are positive. All other trig functions are negative. The reciprocal ones are cosecant of theta is the reciprocal of sine, so it'll be -5/3. Secant is the reciprocal of cosine, so r over x, which will be -5/4. And cotangent of theta will be x over y, which is going to be +4/3 then. So only cotangent and tangent are positive there. And that is my 6 trig functions of that angle that ends at the point -4, 3. So let's do one that ends at the side +3, -5, so down here. So it's going to start with a terminal side at the positive x-axis, go all the way over and end here. Whoops. So let me see if I can draw that a little better. There we go. So this is my theta. So the trig functions I'm evaluating are for that angle that I drew. I know that this is going to be 3, -5, so there's going to be my x and my y. So I can solve for r by using the x squared plus square root of x squared plus y squared. So it'll be the square root of 3 squared plus -5 squared. It's going to be the square root of 9 plus 25, which will be the square root of 34. Now 34 is 17 and 2, so it doesn't reduce any further. So my radius for this circle, if I was to go all the way around, would be the square root of 34. So then I do like to make this drawing of my triangle to help me remember the ratios. So we got theta, we got x, y, and r. This is my opposite side, adjacent side, and hypotenuse. And I use SOHCAHTOA to help me remember it. So I really do draw this at least one time at the top of my paper and keep referring back to it. So then I have sine of my theta will be opposite over hypotenuse, or y over r. Y is -5 and r is the square root of 34. So I can't leave it like that because I can't have the square root of 34 in the denominator. So I rationalize it by multiplying both the top and bottom by the square root of 34. Final answer is going to be -5 square root of 34 over 34. So the sign of that. So the cosecant of sine is going to be r over y. So that's going to be the square root of 34 over -5. So negative square roots of 34/5. So that one's not so bad. Cosine of theta will be adjacent over hypotenuse, or x over r. So adjacent side, x over r, is going to be 3 over square roots of 34. Same idea, you have to rationalize, so multiply both by square root of 34 on top or bottom, and you're going to have 3 square roots of 34 over 34. Secant goes along with cosine. It's a reciprocal, so it's r over x. That will be the square root of 34 over 3. And then tangent is opposite over adjacent, so y over x. So that's going to be -5 over 3. And cotangent of theta will be the reciprocal, so x over y, which will be -3/5. Now notice that we are in, if this is all students take calculus, we're in the 4th quadrant, so only cosine and secant should be positive in your answers, and they are. They're the only 2 positive ones, because only cosine is positive in the 4th quadrant. Okay, if the terminal side of the angle in standard position lies on an axis, then the angle is known as a quadrant angle. Quadrant angles follow special properties. We have 4 quadrant angles: 90 degrees or pi over 2, 0 or 360, 180 or pi radians, 270 or 3 pi over 2 radians. And then you use these x and y properties. So I'll show you an example and make more sense. So we're going to do the 6 trig functions of 90 degrees. Whoops. So I'm going to draw this out. And we got 90 degrees is up here. So I'm going to choose an xy point. So in the last one is it gave me xy. I'm going to choose an xy point on this point, and I want to pick an xy that is going to have a radius of something easy to work with. So if I choose this point right here to be 0, 1, if you think about your circle, then if that's at 0, 1, then the radius will be 1 because it's only 1 point away from 0. So here's my terminal side. I'm going up 90 degrees and I'm picking the point 0, 1, which means that my radius will be 1. So I'm choosing those points. So it told me at 90 degrees, I chose the point 0, 1. I always choose 0, 1. If it was over here, I would choose the point that's -1, 0. So I'd have a radius of 1 down here. It would be 0, -1. You'd have a radius of 1, radius of 1. If it was at 360, I would choose the point 1, 0. You'd have a radius of 1. So if I want to find the 6 trig values of 90 degrees, I still use the same ratio. So if you don't have it memorized, you can draw your triangle. You have x, y, and r. Put your theta here. This becomes your opposite side. This is your adjacent side, and r is the hypotenuse. And then just walk yourself through the SOHCAHTOA. So sine of 90 degrees will equal opposite over hypotenuse, so y over r. So for 90 degrees, my y is 1 and my x is 0. So it would be 1 over 1. So sine of 90 degrees is 1. That means that cosecant of 90 degrees will be 1 r over y, which is 1 again. Cosine of 90 degrees will be adjacent over hypotenuse, so x over r. So x is 0 and r is 1, so 0 divided by 1 is 0. Secant of 90 degrees then will be the reciprocal, so r over x, which will be 1 over 0. And you can't divide by 0, so the secant of 90 degrees is actually undefined. So that one's undefined. Then tangent of 90 degrees will be opposite over adjacent, so y over x. So y was 1, x is 0, so tangent of 90 degrees is also undefined. Cotangent of 90 degrees will be x over y, so that'd be 0 over 1, and that will be 0. So a couple undefined problems there. So if it's a quadrant angle, you pick a point on the quadrant and use that one away as your radius, and then use that point as x or y. So let's do one more. This is for theta equals pi. So remember, pi is over here. That's 180 degrees. So I'm going to choose, this is my theta equals pi. I'm going to choose the point then. This is -1, 0. Since -1, 0 is 1 away from the origin, my radius of my circle will be 1. So then I can use my ratios of my functions, x, y, r. So sine of theta, or sine of pi, I should say. Sine of pi will be y over r, which is 0 over 1, so 0. So then the cosecant of pi will be r over y, which will be 1 over 0. So the cosecant of 180 or pi radians is going to be undefined. Cosine of theta is adjacent over hypotenuse. So my x over r will be -1 over 1. So the cosine of pi is going to be -1. The secant of pi then would be r over x, which is 1 over -1. So the secant of 180 or pi radians is -1 as well. Tangent of pi is opposite over adjacent, so y over x. So that's going to be 0 over -1, so 0. Cotangent of pi will be x over y, which is -1 over 0, so cotangent is undefined. So those are my 6 trig functions of that quadrant angle. So if it's a quadrant angle, you pick a point on that axes 1 away, so you can use the radius of 1, and then x, y, and then use the same ratios. All right, thanks for watching.